cloud. It is a huge collection of millions of tiny, shining dots. All those dots are stars. Into each of them, we could easily stuff in millions of Earths. Our sun is a star too, but it is much, much closer than any of the other stars we can see. By the way, what do you think will be the distance between two side-by-side stars there in the Milky Way? Take those two dots for example. Can you believe it that they are separated by millions of kilometers? But those stars themselves are so far away that they appear jam-packed. In fact, we receive the combined light of all those millions of stars, which makes it look like a cloud. That is the Milky Way's age-old secret. Meanwhile, have you noticed that while we have been chatting, time has been steadily passing? The sky has changed. Remember, we were seeing the Great Bear or Saptarishi. We were also seeing Scorpius, but they have now set in the west. At the moment to the south, there is another famous constellation. Notice those stars. They form some sort of a triangle. That is Capricornus, the sea goat or Makar Rashi, which is famous for the Makar Sankranti that takes place every year in January. To the north of Capricornus, observe those stars. Can you imagine them to be in the form of the letter W? That's another well-known constellation, Cassiopeia Kashyapi, the famous queen of Egypt. Just a little away from Cassiopeia, can you spot that tiny patch of light? It looks like a small bit of a cloud. That is the well-known Andromeda Nebula, which was a mystery for thousands of years. We cannot see it from big cities. Did you ever see it from a village? Let's now observe Andromeda again through one of the best telescopes in the world. As you can see, it is not a cloud. Actually, Andromeda is a collection of approximately 100,000 million stars. Astronomers call such a huge collection of stars a galaxy. Our own sun, too, along with the millions of stars in the Milky Way, which you were seeing a little earlier, belongs to one such galaxy like Andromeda. In fact, there are millions of galaxies. Without our realizing it, the night is almost over, and in these dying moments, notice those stars there, quite high up. They describe a dramatic encounter that is taking place in the heavens. Firstly, can you imagine those stars to be in the form of a bull? That's the bull's face, horns, back. That is Taurus the bull, Vrishab Rashi. Below Taurus, there's another beautiful constellation. Try and imagine these stars to be in the form of a human being. Just see. That's the waist. Those are the shoulders. And those, the legs. That is Orion, the hunter. Kal Purush Mandal. It's as if a hunter is waging a fierce battle with the bull. Literally, at the bull's eye, have you noticed the red star there? That is Aldebaran, Rohini Nakshatra. At the back of the bull, that small group of stars constitutes Pleiades, Kritika, from which we get the month of Kartik. have noticed the pinkish glow of dawn in the east. These are the first fresh rays of the sun. Slowly, the stars are fading away. We do hope, ladies and gentlemen, that in the coming few weeks, you will take some time off to look up at the sky and try to recognize some of the lovely constellations and stars that we have seen today.
The night sky, both beautiful and mysterious. The subject of campfire stories, ancient myths and awe for as long as there have been people. Living beneath the open dark sky, the earliest humans were aware of nightly changes as planets marched across the sky, the moon waxed and waned, and occasional meteors flared across the horizon. Slowly, the simple early observations revealed patterns that could be depended on, leading to the first calendars. With the yearly cycle mapped out, settlements and agriculture could develop and early civilizations thrived. At the same time, the first maps of the sky grouped the brightest stars into familiar constellations, helping to develop navigational skills, expanding trade and aiding exploration. But the first astronomers had no real concept of the order behind the patterns of the sky. These early scientists and philosophers were still bound by a view of the cosmos that was tightly interwoven with mythology. The ancient Greeks, with their rigorous intellectual approach, took the first steps towards separating the young science of astronomy from the ancient sky myths. The greatest minds of the age, such as Pythagoras, Eratosthenes, Apollonius, and Ptolemy, helped in developing a more complete scientific system capable of predicting astronomical phenomena. By observing the apparent motion of the celestial objects around our planet, the ancient Greek astronomers placed Earth at the center of the cosmos, creating the geocentric system. Aristarchus of Samos was the first Greek astronomer to propose the heliocentric model, placing the Sun rather than the Earth at the center of the known universe. But he was largely ignored for many centuries. It wasn't until the 16th century that astronomers such as Copernicus and Kepler revived Aristarchus' view. By studying the astronomical observations of the Danish astronomer Tycho Brahe, supported by solid maths, the heliocentric system gained new relevance. According to this, all planets, including Earth, revolve around the Sun. However, the true revolution in astronomy took place in 1609, when Galileo became the first astronomer to turn a telescope towards the sky. In doing so, he broadened the horizons of the known universe and abolished once and for all the geocentric views of the ancient world. The telescope is an instrument that collects light and provides detailed images of remote and faint celestial objects. Seeing deeper and further depends on collecting more light, usually requiring larger lenses or mirrors. Today, scientists have huge telescopes, supported by state-of-the-art instrumentation and sophisticated software to study the universe and discover its secrets. ESO's Very Large Telescope has 4 8-meter mirrors, and they can detect objects as they were just a few 100 million years after the universe began in the Big Bang. For the best results, these giant telescopes are most often located in remote mountain regions above much of the atmosphere and away from widespread urban light pollution. With their help, we can see deep into space and through the fog of time to reveal a universe inconceivable to the people of the ancient world. A universe which is vibrantly active and violent, and where the game of life and death is played out on a scale that humbles all who observe it. In the last 50 years, we have reached out into space, leaving the bonds of gravity behind, and opened a new era of exploration. Thanks to the space program, we have seen our planet from an outsider's perspective, as a fragile, pale blue world orbiting the sun, frighteningly vulnerable in the cold and hostile environment of space. Space technology has altered our way of life and changed our perception of the world from a place defined by maps and borders to that of a small and insignificant body in space. The benefits derived from the space program have a value many times higher than the cost and effort involved. With space exploration came the technology that has placed telescopes above the atmosphere of our planet. Space telescopes that can record a fresh view of the universe, observing in wavelengths that cannot penetrate the Earth's atmosphere. Each new generation of telescopes, from Galileo's first simple instruments that showed us the moons of Jupiter, to the Hubble Space Telescope, has opened new windows on the universe and challenged our understanding. Step by step, we have been displaced from the center of the world and placed as exiles on the edge of a vast and inhospitable universe. Today, we know that the Sun is an average dwarf star with a diameter of just under 1.5 million kilometers, and that it lies 150 million kilometers from Earth. The Sun is a sphere of gas, with a core where temperatures and pressures are so high that nuclear fusion is triggered, converting hydrogen into helium, all the while pumping out energy into space. Energy that warms and sustains the Earth, supporting life in all its oceans and across continents. Periodically, on the surface of the Sun, a localized strong magnetic field forms, creating a sunspot. Here, energy can accumulate, which is then often released into space in the form of huge explosions, known as flares. Solar flares can be accompanied by a burst of high-energy particles flung out into space, sometimes reaching Earth and disrupting communications, as well as generating spectacular northern and southern lights. Currently, the Sun is in a very stable state and will continue to radiate energy at a steady rate for another 5 billion years or so. But eventually, the fuel powering the core will run out, and the Sun will slowly cool and expand to become a red giant, engulfing all the inner planets, including the Earth. Mercury is the closest planet to the Sun, a lifeless world with a very thin atmosphere. Its surface is littered with craters created by collisions with tens of thousands of asteroids and comets. In 2004, scientists sent the space probe Messenger to Mercury to study this alien world. Messenger has provided a wealth of scientific data, as well as high-resolution images of the surface of the planet. Venus is roughly the same size as Earth, but its atmosphere is choked with greenhouse gases and sulfuric acid. As a result, its surface temperature reaches a searing 400 degrees Celsius. The surface of Venus is known to still be geologically active, with fresh lava flows. The third planet from the Sun is the Earth, with its liquid water oceans and oxygen-rich atmosphere. The Earth is an oasis of evolved life in the solar system. The Moon is our natural satellite, with a diameter roughly 4 times smaller than Earth's and lacking an atmosphere. The Moon's surface is covered in craters, which, as on Mercury, are the result of thousands of collisions during the early stages of the formation of the solar system. The Moon is the only celestial object that has been visited by manned space missions. Mars is the fourth planet from the Sun, only 70 million kilometers away from Earth at closest approach. Scientists have been exploring Mars systematically for the last 40 years, and we now know many of its secrets. We have mapped its surface remotely, showing its numerous craters, enormous extinct volcanoes, and its deep canyons. There was almost certainly water on the red planet long ago. Now only small quantities of underground water remain. It is possible that a simple form of life could persist somewhere below the surface. Scientists continue to explore Mars with small remote-controlled vehicles, and it will be the target of several